Alright, so in this video we're talking about solving radical equations by hand using algebra, but remember, like we said in the previous video, almost any equation can be solved by graphing. The important thing to remember here is a radical is essentially that check marker looking shape, okay? And we always have a number in front of the radical whether or not we can see it. That number n is called the index of the radical. We have a couple rules about n. If n is odd and the number underneath our radical is positive, then x has only one solution. If n is even and x is positive, then x has two real solutions. And then if n is even and x is negative, then x has no real solutions. That means we're going to have complex solutions. So just keep those in mind. All right, a couple examples. We're going to solve each one of these. But to remember, to solve a radical equation, the index and the power that we're going to use to cancel out that index must match. Okay, so very first thing you want to do, anytime you're solving a radical equation, you want to get your radical, aka that check mark, you want to get that piece by itself first. So I'm going to say plus 4 to start with on the first example. Cancel out. So I have, just bring it over here, the cubed root of x equals positive 4. Here my index is 3, so I'm going to have to use the third power to cancel it out. Okay, so now the third power and index 3 cancel out. All that's left is x. So x is equal to 4 cubed, which is 64. Now, if you didn't know that 4 cubed is 64, then definitely use your calculator, do that scratch work. There's no shame in that game. 4 cubed, 64. It only takes a few extra seconds, so I'd much rather you use a calculator, do the scratch work, and get it right, instead of letting your pride and your ego get in the way, and you guess and you get it wrong. Okay, let's do another example. Here in this one, I want to get my radical by itself, but notice that there's no number that I can see in front of the radical. Anytime that happens, that's called a regular square root, and for square roots, the index is always 2. So I'm going to go ahead and write that 2 there. Okay, so index is 2 for regular square roots. My very first step is subtract 2 on both sides. So I have the second root, aka the square root of 4x minus 7 is equal to positive 3. Well, to get rid of my index 2, I need power 2 on both sides. Okay, so I'm going to do power 2 on both sides. Okay. Power 2 and index 2 are going to cancel out, so I'm just left with 4x minus 7 equals 3 squared, which is 9. And I want to clean this up now. It's a pretty easy equation. Everybody should be able to do this. First step is now add 7. So 4x equals 16. And now I want to get x by itself. So divide by 4. So x equals 4 if I clean up my fraction. No big deal. All right, I did my last example. Let's do that one in red. I have 2 radicals on the same side of the equation. It doesn't work that way. What you have to do is your very first step is to get 1 radical per side. So I'm going to move this negative 2 square root of x over to the right hand side. Since it's a little bit smaller, probably going to be easy to work with. So to do that, I'm going to say plus 2 square root of x on each side. Cancel out, so this square root falls down. Now remember, if I just have regular square root, then the index is 2. So each of these have an index of 2. I'm going to go ahead and write those in. And to get rid of that index 2, I'm going to need power 2. Okay, so let's do that. Power 2 on each side. What you do on one side, you have to do on the other.
Okay, yes.
Okay. So here, the power and the index must match to cancel out. They do. So 3x plus 2 equals. Now, you got to be careful with this side. Obviously, power 2, index 2 is going to cancel out, so x is going to fall down. But what about the 2 on the outside? Well, that 2 is still being squared, so 2 squared is 4. If you don't square that number on the outside, the equation is not going to come out right. Now we're ready to keep going. So we have, I want to get my x's on the exact same side of the equation, so I'm going to take 3x over to the right. So 2 equals 1x. Now I want to get x by itself, so I'm going to divide by 1. So x equals 2 over 1, which if I clean up that fraction, it's just equal to 2. Okay? A little bit more complicated. I have a number in front of a power. Okay? So when I have a power equation, especially if my power is a fraction, then to cancel that power, I have to flip it. Okay, so let's do an example. The very first thing you want to do though is get that piece that's got the power by itself first. So that means for this problem, I'm going to have to get rid of 3/4. And I'm going to do that in 2 steps. The first step is to multiply by whatever number's on the bottom. In this case, it's 4. Okay, the 4 is going to cancel out, so I'm just left with 3x to the 1/3 power equals -8. And now I still want to get my piece with the power, get that by itself. So I need to divide by 3. Cancel out, so x to the 1/3 power equals -8/3. Okay, great. Now, my power is a fraction. To get rid of it, I need to flip it. So that means I'm going to have to use the 3 over 1 power on both sides. Okay? When you do that, the 1/3 power and 3 over 1 power are going to cancel each other out. So I'm just left with x equals, now, -8/3 to the 3 over 1 power. Let's type that in. Before you do though, our power is a fraction, so you're going to need parentheses. Also, it's up in the air, so you're going to have to hit that power key. If you don't do both of those things, it's not going to come out right. Also, your base of your power is a fraction, so be sure you keep those parentheses there. So let's type it in. So parentheses -8/3 raised to the 3 over 1 power. Okay, and you get -18.96. So a decimal, no big deal. We're just going to round the 2 decimal places, -18.96. Okay, great. So remember, when you're solving a power equation, you want to flip that power to cancel it out. Do another example. Here, we're reminded that when the power is even, we got to consider 2 solutions, positive and negative. So, again, it's a power equation, so I want to get my piece with the power by itself first. So for this particular problem, I want to divide by 3. So I have x squared equals 27. Again, if you struggle with 81 divided by 3 in your head, use your calculator and do that scratch work, please, I beg you. Okay? Now, again, my power is even, so I have to consider 2 solutions. Also, to cancel out that power, I need to flip the fraction. But I don't see a fraction here, or do I? Remember, any number can be written as a fraction by putting it over 1. So that would mean that for this problem, to cancel out 2 over 1, I need to use the 1/2 power on both sides. So 2 over 1 and 1/2 are going to cancel out, and that just leaves me with x equals 27 to the 1/2 power. But since my power was even, I need to consider plus or minus, okay? Positive and negative. If you don't do that, you don't have both the answers. So now what I want to do is just turn this into a decimal. So, or actually before I'm going to turn it into a decimal, I can leave it like this because I have x by itself, or I can split it up into 2 separate answers. So x equals positive 27 to the 1/2 power, and x equals negative 27 to the 1/2 power. Those are my 2 answers. Let's convert each one into a decimal. So clear it out, clear it out. So I have 27, I'm typing in exactly the way it looks, to the 1/2 power. Again, my power is a fraction, so I need to be sure to put that in parentheses. If you don't, it will not come out right. And I actually meant to do that on my main screen, so 27 to the 1/2 power is 5.20 if I round. Okay, let's convert the other one to a decimal. Okay, negative 27. Now, here I have 27 in parentheses, that's important. So I'm going to put negative parentheses 27 raised to the 1/2 power. I get negative 5.20. If you don't put that 27 in parentheses like it is here, again, we did parentheses in our problem, so we need it. If you don't type that in the calculator way, it's not going to come out right. So you've been warned. Please do what I suggest to you. Now what I'm going to do for this particular problem, just to verify that I've got the correct answer since I had two solutions, I'm going to graph it. When in doubt, always graph it out. So left side's always line 1, right side's always line 2. Okay. So what I'm going to say, y equals, clear it out, 3x squared, 81, and graph. I hit zoom 6. Now I know I graphed two things, but I only see one thing, so that implies that I need to zoom out. Still only see one thing, so I'm going to zoom out again. And now I see two things. We saw that our original graph was a U shape, so this line that's going across is going to touch in two places. Somewhere over here on the left, somewhere over here on the right. And I'm going to kind of exaggerate that a little bit because I don't want my calculator to get confused. So now I'll go through my process. Second calc, option 5 for intersection. First curve enter, second curve enter, yes. Okay, so I have negative 5.20. Now find the other point of intersection. Second calc, option 5, first curve enter, second curve enter, and guess. I get 5 positive 5.20. So we did it two ways. We did it by hand and by graphing, and we got the exact same answer, so everything's good. All right, and then a few more examples. Sometimes when especially you're working with radical, rational, or logarithmic equations, you're going to have what's called a false solution or extraneous solution. So let's do a few examples of those. In this particular example, my radical is always by itself, and it's a regular square root, so I know that the index is 2, so I'm going to go ahead and write that there. To get rid of that index 2, I need to use power 2 on both sides. Now, x minus 4 is tied together, so you got to put the parentheses around it like that. Power 2 and index 2 cancel out, so 2x just falls down, and then x minus 4 squared falls down. Now, you can either expand this binomial using FOIL or the box. I'm going to do the box scratch work to show you what that looks like. Or you might be able to do that in your head. I can, but I'm going to just show you this scratch work that way in case you haven't seen the box before, because the box is really useful. So x times x is x squared. X times negative 4 is negative 4x. X times negative 4 is negative 4x. And then negative 4 times negative 4 is 16. Now I'm going to combine my like terms, so I have x squared minus 8x plus 16. So that took care of this piece over here on the left. And that's equal to 2x. Now to solve this, I want to get everything on the same side. So I'm going to subtract 2x. So x squared minus 10x plus 16 equals 0. All right, so I'm going to solve by factoring, which is a method that you should have known from a previous class. So I'm going to go over that in later videos in this chapter. But if you struggle, especially with the factoring part that I'm about to do, please go back and review some of those videos or get help from me in person, okay? Because factoring is really a skill that you need to know how to do, and it's something that honestly you're kind of expected to know how to do at this point. Okay, so I'm looking for factors of positive 16 that'll add up to negative 10. Okay, so I'm going to say, let's see, factors of positive 16 that add up to negative 10. So how about x minus 8 and x minus 2? And that's still going to be equal to 0. I need to double check, make sure I pick the right numbers. First off, I'm going to multiply negative 8 and negative 2, which is positive 16, so that works. And then I'm going to add negative 8 and negative 2, which is negative 10. So that's my double check. As soon as I have my two factors, I can use the property called the zero product property, which means I take my product that's equal to 0 and I just make two smaller equations. X minus 8 equals 0 and x minus 2 equals 0. And then I'm just going to solve each one of these. So plus 8 each side for the first one. So that tells me x equals 8. For the second one, I'm going to say plus 2 each side. So that tells me x equals 2. Now, since I had a radical equation, I must check for extraneous solutions. So what I'm going to do is take each solution and plug it into the original problem. That's very important. When you're checking for extraneous, you must plug into the original problem. Everywhere I see an x, I'm going to plug in an 8. And this is just scratch work, so I'm going to do that on the side. So I have, for x equals 8, let's do that in yellow. So I have 8 minus 4 equals the square root of 2 times 8. Clean it up as much as I can. So 8 minus 4 is 4 equals the square root of 16. And we know the square root of 16 is 4, so 4 equals 4, which is true, that works. So x equals 8 is called a valid solution or a true solution. Valid is just a fancy math word for true. Let's do the scratch work for x equals 2 in purple. Same thing, I'm going to plug into the original equation. So I have 2 minus 4 equals the square root of 2 times 4. Or sorry, 2 times 2. Clean it up as much as you can. 2 minus 4 is negative 2. And that's the square root of 4. But we know the square root of 4 is positive 2. But this is saying negative 2 is equal to positive 2, which makes no sense at all. This is not true. So that means that x equals 2 is an extraneous or a false solution. Extraneous is just the fancy math name for false. And once we know it's extraneous, we just ignore that solution. We pretend it doesn't exist. So even though we found 2 possible solutions here, when we checked it, we only had 1 valid or true solution. And that's it for this video. Just remember, anytime you're looking at radical, rational, which will be the next video, or logarithmic equations, you want to check for extraneous solutions, okay?